Good evening. My name is Hani Mamastani. I'm the director of the Transportation Center, and as the Patterson chaired professor at Northwestern, it is my distinct pleasure and honor to introduce our special guest today, Dr. Irwin Jacobs, who is our 42nd distinguished Patterson speaker today. The Patterson chair at Northwestern and the Patterson lecture was established 32 years ago to honor William Patterson, who at the time was chairman of United Airlines, and it has become the focal point for transportation activity at Northwestern as an annual event. And not just at Northwestern, but really in the transportation industry. There is no sort of higher honor than the Patterson lecture in terms of a university recognizing the contribution of a leader in the transportation industry. And over the years, we have featured again many distinguished leaders and innovators in transportation, from the auto industry, from airlines, railroads, and so on, and trucking industries. This year, our speaker is a very special one, in the sense that many might not have considered telecommunications to necessarily be a transportation industry. And part of what we're recognizing here today, of course, other than the tremendous contributions of our speaker that I will be mentioning a little later, we're also recognizing the tremendous role that telecommunications, particularly wireless telecommunications, has played and is playing and will continue to play in the transportation field, and more generally in the realm of mobility, both personal mobility as well as freight and logistics. So Dr. Jacobs is an accomplished academician and industry leader, an innovator and a visionary. Starting out as an electrical engineer who received his undergraduate degree at Cornell and graduate degrees from MIT, he went on to teach at MIT. He joined the faculty at MIT, was an assistant professor, then associate professor, and at some point he decided that he wanted more sunshine, and moved on to San Diego, where the University of California at San Diego was being launched, and was one of the pioneering professors there in electrical engineering. By then, he was, of course, an accomplished academician, having published many papers and books, and really uncovering sort of the fundamentals of what was then to become a major innovation in wireless telecommunications. From academia, he went on to launch an iconic company called Linkabit, and from Linkabit then moved on to Qualcomm. And many of us know Qualcomm for what we have in our pockets, for our cell phones, if we do, because most of our cell phones are powered by Qualcomm chips, and a lot of the protocols and so on that are moving these bits are all patented and Qualcomm owns a lot of the intellectual property that has provided us with this with this wonderful technology. But Qualcomm has also been an innovator in the logistics field, because one of the early businesses of Qualcomm was in asset tracking and trucking. And I believe Dr. Jacobs will tell us more about that. That's the OmniTRACS part of the business. But certainly went on and had a huge impact on the, again, telecommunications industry, but on everything that is really touched by that. Dr. Jacobs was the CEO of Qualcomm through the, it's from startup all the way to Fortune 500 company, and probably saw its stock price go several orders of magnitude, and again, just really reach out and impact so many other sectors here. He is currently, he's founding chairman, of course, and he is CEO Emeritus, so he has more time to go around and talk to groups such as ours, and he also has time to partake in his generous philanthropy in the arts and the sciences, and contribute in various other ways. For example, he chaired the board of the Salk Institute. He chaired the National Academies of Engineering for 4 years in 2009, I believe, and has been decorated and recognized in more ways than we have time to talk about today. So without further ado, it's my honor and pleasure to introduce Dr. Jacobs.
Thank you very much. Is that working okay? Yes? No? Yes. Can you hear? Whoops, flip down. Little logistics. Testing? Yep. Better. Okay, I'm sorry. Good to be here with all of you today. As you can tell, a little bit out of place being a communications person in a transportation group. But you'll see there are indeed connections. And of course, these days with wireless expanding so much, it becomes part of just about everything that we're doing, and I'll try to touch on a few of those different areas. I'll start with just a little bit of history, filling in a trifle. I was an undergraduate at Cornell, as was my wife. We met there sophomore year, so we've been together for quite a long time, successfully. And decided to then go on to MIT for graduate work, just to get a sense for how things have changed. In my last year at Cornell, I took a laboratory course and theory course on vacuum tubes. So if you need to have any questions answered on vacuum tubes, I could help. And as a result, kind of grown up through just about every generation of computers, including now the fact that we carry them around in our pocket, and I'll come back to that case as well. Originally, when I went to MIT to graduate school, I thought I would be studying electromagnetic theory and antennas, because that was a subject that I enjoyed very much at Cornell. But at the time I arrived at MIT, there was a great deal of excitement about information theory. And that caught me up, and so I studied information theory, did actually a doctoral thesis on networking, and stayed on to teach, as was mentioned. We started to teach one course on communication theory, and we decided we'd bring information theory into it. And at the time, everybody thought information theory would probably be something of applied mathematics, not have too much practical import. But we felt that indeed it was the future. And so we taught the class a number of times. It was an undergraduate class, wrote the textbook, and it was now the first textbook really on digital communications, and that's what we all live with these days. That had an impact. We took 1 year's leave from MIT to have our one visit to California, came back. Just after coming back, had an invitation to go and teach and help start engineering at the University of California, San Diego, which was just starting. We turned that down, but after 2 days decided maybe that was the wrong decision. Called up and said, if it's still open, we're coming. So off to California. And that actually had more of an impact than I had initially thought, in that because of the textbook and the background digital communications, there were all these requests for consulting. And typically on a faculty, you'll consult perhaps one day a week. And so I mentioned to some faculty friends from UCLA that I had all these requests for consulting, and they said, oh, let's start a company and share consulting. And so that was how the first company, which was called Linkabit, kind of a somewhat humorous name because we weren't too serious about the whole thing, started, but it began to grow very rapidly, and a lot of exciting things were happening. We had to hire a number of full-time people, and it kept growing. I'll show you that in a second. And so then I decided perhaps I better take a year's leave and get it organized. So did that, found business was quite interesting, and I guess in this building I don't have to say that too strongly, but found the business part was quite interesting, as well as the technology. And I decided to leave academia, go into business full time, and rationalize that to a certain extent by saying, well, we've been teaching all this theory for many, many years. There are a lot of people that are skeptical whether the theory ever has any use to it. And so here's a way to show that, in fact, the theory is very useful. And so with that rationalization, decided to go full-time into business, and that was Linkabit. Now, we didn't have a business plan. As I mentioned, we started as a consulting company, but knew we wanted to develop products, innovative products, not just do something a little bit different, but see if we could do something significantly different, and then hopefully even get into manufacture and not just talk about things. And so in doing that, we then luckily proceeded through a number of actually very fascinating products. One of the early ones actually was a contract from DARPA, might have been called ARPA at the time, to extend the ARPANET over to Europe. And the way to do that was through a satellite connection. And we were experts on the communication on the satellite part, but of course you had to get somebody over in Europe to be able to work with on the other end of things. Went over and spent time visiting each of what were then called PTTs, Postal, Telephone, and Telegraph, I think. And we would always be invited in for a very nice lunch. But after lunch, we'd quickly be exited out because who was interested in packet communications? In any case, we finally did find a couple of universities to work with, a few government laboratories to work with, did extend the net through what we called SatNet over to Europe. And as a result of that, participated in, at the time, something none of us really thought about too much, but the very first practical use of the Internet protocol. We had the ARPANET in the US, we had the SatNet going over to Europe, and it was what's called a packet radio program here in the States, and each with a different protocol, connected those together using the Internet protocol, and it worked. And of course, we didn't think too much about it until in 2007, the Computer History Museum discovered this and had a 30th, I think it was, anniversary. So that was the first time we really thought about the fact that we had played a little bit of a role in the coming of the Internet. And of course, it's come a long way, and it continues to play a role in just about everything we do. We did a number of other innovative products. For the first 9 years or so, we were mostly doing different types of government work, but we developed a communication terminal using what's now called RISC computing, reduced instruction set computing. I'll come back to it because it turns out to be one of the battle areas today in how do you build mobile devices with computers in them. In any case, it was still a university thing. We didn't know about it at the time, but we thought it would be the best way to do this. Built the terminal. You can see the picture there on the upper center, and a control head and a little box. And we were competing with another major company for a manufacturing contract for this, except they built it by more traditional means, and so they had several racks of equipment. Had to go up to a commanding general up in Los Angeles in the area of the communications and satellite area, and he had been briefed a bit about what we had been doing. We're still in a prototype phase, and he looked at me and he said, look, I'm a project engineer for this. There's a major company who's done many projects for me that have been successful. Yes, they might have a few problems here or there, and it may not quite meet all of our requirements, but you know, I have confidence they'll be able to come through. And I thought at that time, boy, that's the end of it. Okay, I understand. So he paused, and then he looked at me and he said, but as a taxpayer, we're going to support you to be able to go ahead and compete on this production, which we won and built almost all of the units. And as far as I know, they're still operating. Being based on computers and with read-only memories getting larger all the time, one can add more and more capabilities to these devices, so it really has turned out to be a great investment. We got into another, this still at Linkabit, other interesting areas. We had a program with Schlumberger, how do you get data back from a drilling site to a customer so they can decide whether to keep drilling or to give up on that hole and move on to another one. And then we took that and reduced the cost of it, since it wouldn't have to be handled by people with big gloves on, et cetera, and sold the first ones to Walmart to connect all their stores and to connect their inventory centers, et cetera, warehouses. And in some sense, that was our first introduction really to logistics. It was kind of an interesting program. And Sam used to use the system to send out a message every Friday to all the employees to kind of build up morale and urge them on. And finally, we ended up doing something called Video Cipher, initially for HBO, to scramble the signals coming from satellite. Originally, it was supposed to go to cable heads, but we won the contract. We're all ready to build a unit for cable heads, a professional unit, in other words, and we suddenly bumped into our first real encounter with government issues. A group of backyard dish owners decided to go to Congress to convince Congress not to allow this to happen. They said, we're willing to pay something to get our signal, but you can't just take it away entirely. And they were getting Congress to agree with them. And so HBO thought, well, we better build a unit and go to the home, which of course had to be much less complex, much lower cost. They almost actually backed out of doing this, but they did have, forget scrambling, let's just continue the way we have been. But they had one customer who had a favored nations clause, for those of you in the legal side of business, which basically said, we get the best deal. If you're giving somebody this at some price, you can't charge us any more. If they're giving it away free to the backyard dish owners, you have to give it to us for free. That caused HBO to decide they better continue to with this descrambling business. And at the time, we had sent some people out. This is when chips, integrated circuits, that go in all your electronics, when these were still being designed manually and cutting out Ruby to make the mask sets. A very slow process, and initially at Caltech, and then MIT, University of Washington, maybe here. Others were beginning to think about how do you design these by computer. I had one of our engineers go up to Caltech for a term to learn more about it, and we went around, gathered some information. Everybody came back. I was getting ready to have some homework problems, basically. Let's put some software together, do some homework, when suddenly we had to design this home unit for HBO. And to do that, the only way to make it reliable, inexpensive, and small was to make 3 integrated circuits. The only way to do that was to use this software that had never been tested. Well, we made those 3 chips. They all worked the first time, and that turned into a monopoly. Actually, I sold the company, and just after I sold it, they then sold this division to General Instrument, who went private-public twice on the basis of this particular project. So in any case, we started out without any products in mind, but kind of moved ahead. We're very opportunistic, looking for good chances, trying to prepare ourselves if a chance came along that we could move with it, and built up an interesting business. This is a quick view of the sales. We continually went up 50% or so per year, and always profitable. So it was a very good business, but we did sell it. Retired for 3 months, decided after 3 months that probably wasn't the right thing. I don't think Joan threw me out of the house, but might have come close. In debating what to do next, decided, well, Linkabit had been fun. We'll start another company with 6 other people that have been with me at Linkabit. But probably it's not going to grow the way Linkabit grew. And so I told Joan that maybe we'll get up to 100 people. And so this was Qualcomm, standing for Qualifications. Started on July 1 of 1985. And again, we didn't have any products in mind. We didn't have a business plan, no Excel spreadsheets, nothing that you'll be taught how to do properly here in the School of Management. But we knew wireless, we knew that digital, these things were going to have a future, and hopefully we'd find something interesting to do with. And I must say that within probably the first 6 months, we came up with various ideas that have pretty much kept us busy ever since, taking them and then elaborating on them. We came up with the idea of code division multiple access, and I'll come back to that. The idea there was to use it initially for a satellite system, but hopefully later for cellular, if cellular would continue to expand. We're doing it under a consulting contract with Hughes, where they wanted to launch a mobile satellite system. They had applied to the FCC. Unfortunately, the FCC was interested, but it was going to take 3 or 4 years to ever approve it. And so they weren't willing to fund any work along these lines. We didn't have the resource to pursue CDMA at that time, and we have been pursuing a product for the transportation industry to provide the communications between trucks and headquarters, and also give the headquarters the exact location of the truck, something we called OmniTRACS. It was actually quite an undertaking. One of the things we had to do was design an antenna to go on a truck that, as the truck drove around, would continue to point at the satellite and provide significant, what is called gain, 19 dB of gain, toward that satellite, and do that with a very inexpensive but highly reliable antenna. And that's where, luckily, I fell back on I mentioned I was interested in EM theory, electromagnetic theory, and antennas from Cornell, fell back on that, came up with a design, and that design pretty much has worked ever since. So we came up with an OmniTRACS system, and the system used one transponder on a existing commercial satellite to send signals to the trucks, and another transponder to receive the signals back from the trucks. So we could use a couple of the transponders, typically there were 16, now many more, on a satellite, and as a result not have a huge operating cost up front, which are obviously very critical. We had a competitor who was very heavily funded, who wanted to launch their own satellite and therefore be able to have more powerful transponders, et cetera. And so we were competing with them. They did launch part of a service, but about once a week I would do a business plan for what it was going to cost us, what our revenues might look at, then compare it to what their situation was, and we always looked better, and so we kept working at this. We signed our first contract to deliver equipment in October '88 with Schneider National, and that was a hallmark in some sense for the industry. The system we were selling, the communication part of it, involved a satellite that talked back, was connected back to a control center at Qualcomm, and then by landlines out to the various trucking headquarters, logistics centers. And for position location, initially, we started out using something called LORAN. I don't know how many of you might recall LORAN, but it was developed during World War II for position location for the military. And the remnants of it were still available over the US. It had actually been designed at the radiation lab at MIT. There's an interesting book about that. So we started using that. The only problem was that if you got near a gas station that had fluorescent or neon lights or something, it would just send the position location ARI. I mean, just ruined it. So then we had to come up with another idea, and this was before global positioning system, GPS, was available. We came up with the idea, okay, we have the communication signals. If we put another signal on a second satellite and use that for a beacon, and be able to measure time differences knowing where those two satellites are, we could do a good job of position location. But we only had one antenna, normally pointing at the communications, and so we set up a little algorithm so that ever so often it would sneak a look at the second satellite, get a measurement, and come back again. Worked fine until GPS came along. So again, one has to roll with these various punches. I'll mention one other aspect of that. You're probably going to be getting more communication stuff here than you might be interested in, but in order to get a signal even to this 19 dB gain antenna, we had to use the full strength of the satellite signal transmitting from the satellite to the truck. And these satellites were mostly being used for television, talking to fairly large, comparatively large antennas. And we had to be able to do this without interfering with those. One way we did that was spread spectrum, which is exactly what we use in CDMA. So that worked reasonably well. But we needed to send digital information and code it. And there were, I mentioned VSATs from Linkabit, very small aperture Earth terminal for business communications. Well, people started to make those, make cheap versions of them that didn't have the coding in them that would be resistant to the kind of signals we wanted to transmit. And so we were all set to get turned down by the FCC, the Federal Communications Corporation. What can we do about that? And so we decided to make our digital communication signal look like a TV signal that's actually coming down from these satellites, so that you couldn't tell the difference. Any VSAT had to be able to work with a TV signal, therefore it would work with our signal. In all the years since, and these systems are still operating, many of them are operating, and we've never had a case of a proven case of interference. Nothing's ever occurred that gave us trouble. So all this went ahead. On the other hand, when we went to sell these units, we found, well, that's interesting. Communications is interesting, but that's not by itself going to do us any good. How do we make money on communications? You've got to integrate that entirely into our logistics system and provide all types of other capabilities. And so I had a whole education on logistics, on the complications in the transportation, particularly the trucking business, on all those things you need to do to have a complete system. And that's, of course, proved valuable ever since. Well, that business continues on in very good shape. We have various terminals for communicating directly with the driver, all types of software now. You can read down some of those items there that do integrate very well into the systems, provide useful information. And we found that indeed it was both profitable for the companies to have this, and perhaps even more importantly, useful to the drivers. One of the issues we had up front, first of all, was that at that time, drivers had never worked with a digital keyboard, and so we were told that the panel should only have numbers, but that was very limiting. And so we said, no, we should really have alphanumeric. Couldn't quite win the argument, so we put out terminals that had both ABC type alphabetic and QWERTY, the usual typewriter type. I don't think we ever sold an ABC one. QWERTYs, drivers learned that we were very careful of the interface. Drivers learned to use these in a very short time, like half an hour or something, and that turned out not to be a problem. The other problem was the big brother problem. Your dispatcher knows exactly where you are at any time, where the truck is at any time. Okay. And we thought, well, perhaps drivers are going to drive under a low tree branch and knock these things off, or put metal over the antenna or do something strange to them. But drivers very quickly found that A, they didn't have to continually be looking for a telephone booth to find out what to do the next day, or wake up in the middle of the night, or they could get more business. Their salaries went up and their lives became better, and they became our strongest supporters. So that itself was very interesting. And so we learned we needed to integrate into the systems and make sure that all of the people involved, the owners operators have a good income, drivers have a good reason for wanting this in the cab, and we are making enough money to make it practical to continue. So once we had that sale, we came back to look at the use of CDMA, which stands for Code Division Multiple Access. I won't go into the technical details at this point. But the cellular industry had recognized that although initially there were consultants that said maybe there'd be 100,000, maybe even 1 million cell phones by the year 2000 or later, that the industry was growing, that it was going to be more and more popular. And so the manufacturers and operators began to look for a way to go from what's called the first generation of cellular, which was based on analog FM radios, over to a second generation based on digital technology and digital transmission. And there were 3 approaches for doing that. One called FDMA frequency division, second time division, third code division. And so laboratories, large companies around the world had been spending a couple of years researching which way would be the best way to convert to digital. Now actually my first company, Linkabit, we had also designed for another company the very first commercial CDMA telephone. So we had background in time division multiple access. But as I mentioned earlier, we'd come up with this idea of using code division multiple access for the satellites. Once we had the sale of the first sale of OmniTRACS to Schneider, we began to look back at using CDMA. Well, it took until the end of February of '89 for us to be convinced that, yes, this really does look positive. We think we've got solutions to the hard problems. It could be practical. End of February. In January, the industry had a vote whether to go with frequency division or time division. They threw away code division because everybody, after researching it, said it was too hard, would never work, didn't give any useful results, might take forever. In any case, nobody else pursued code division. Had a vote in favor of time division. So we came along the next month to say you need to look at code division. And they said, we've just been through this battle, don't bother us. Well, luckily we found an operator that looked a little further ahead, and this was Pactel, looked a little further ahead and said, look, the time division is going to get me perhaps 3 times as many customers in a given amount of radio spectrum per antenna. And CDMA, we said, perhaps could get up to 50, but in the early stages, maybe 10 to 20 times the capacity. So there was a significant potential improvement. By the way, we these days are up to about 50. And so at least they were willing to listen a little bit. They then set up a meeting with maybe 50% more people than we have here to hear about CDMA. And I went to give us a meeting, actually here in Chicago, come to think of it, in June of '89. And I really thought somebody was going to raise their hand and said, you missed this key point, forget the whole thing. But nobody came up with a problem like that. But of course, nobody believed us either, because all I was doing was showing slides. And so we had to build a demonstration system. And we did that the way that startups usually do things. You work day and night until you get it done. And we had to move quickly because the rest of the industry is marching toward building commercial TDMA systems worldwide. In September of '89, so 3 months later, had to decide whether to invite people in to see our demonstration system, which of course was not yet working. Looked around. If I took a vote, I knew I'd probably get 9 out of 10 saying let's wait, but we couldn't really afford to wait. But I had enough feeling that, yes, we've made enough progress, we probably will get it done. And we sent out the invitations. People came in November of '89 to see CDMA. Well, as I show in the picture here, the mobile terminal required a van to drive it around. And then we had a couple of base stations. We started talking to the group, and I was presenting information, getting prepared to send them out to hear the phone on both sides, and suddenly had someone at the back of the room stop waving, keep talking. That's the advantage of being a university professor, so I kept talking. And about 50 minutes later, I had, thank God, another hand wave that it was okay to send everybody out. And what had happened, we were using the global positioning system, the GPS satellites, which were still experimental. They hadn't been commissioned yet, gone operational, to drive a time and a frequency signal. One had come over the horizon with a bug, threw our system off, took a while to figure it out. That was the problem, resynchronize everything, and get it working. Luckily, it did get working. Any of you that have companies or have started companies, you can probably think of at least a dozen at different times when, if the luck of the draw didn't quite go the right way, you would have been out of business. This was certainly one of those cases. Luckily, it did work out. As a result of the demonstration, several of the operators became very interested in what we're doing. A couple were skeptical. They said, okay, this works in San Diego, will work in Manhattan with the big buildings, with signals tunneling down the avenues and the streets, colliding at an intersection, et cetera. You have to go and demonstrate in Manhattan. So we packed everything up, took it to Manhattan, and my favorite memory of that is of having a van parked down. We had to do it at night because during the day they needed all the spectrum they could for the first generation of cellular. So we had this light, and people would come up, look in the windows of the van, see everybody crouched around terminals doing various technical things, get scared that it was a police bust, and run like crazy. So nobody ever bothered us, luckily. It did work, and we proceeded on. And that raised the next problem. In order to go to commercial equipment, we had to develop these little chips again to make it fit into a commercial-sized handset and infrastructure, base stations. And that was going to cost us a lot of money, and how do we get that money? And so, again, innovation. Innovation does not only apply to products, it applies to just about everything you do in business. You always have to think the business plan, how do you do purchasing, how do you HR, whatever it is, you can always do something a bit better and differently. In any case, we came up with the idea of licensing this technology. It was yet to be proven commercial. Luckily, the operators were now quite excited that we could give them much more capacity, and they urged the manufacturers to sign agreements with us. And so we signed first with AT&T, and then with, which Lucent hadn't spun out yet, and Motorola, Nokia, a few of the large ones, urged on by the carriers. And the deal was that they'd pay us an upfront license fee, which would give us money to keep the R&D going. And then in the very small chance that this ever did become commercial, they'd pay us a royalty on each handset. And it was not a particularly common plan at that time. In fact, it might have been one of the very early ones, if not the earliest. But since nobody really believed in it too much, we did get people to sign up. That gave us the funding to go and develop the chips to make the first handset. We invite everybody back in November of '91, so just 2 years later, to see a commercial-sized handset. It took 3 chips to just do that second generation CDMA only capability, but that was enough to make a commercial-sized handset. We did the same for the base stations, brought everybody in, convinced them that this was, in fact, doable. Now, it's very interesting to see what's happened since. By the way, we had a key strategic decision to make a little later. We did several key strategic decisions to make. We did convince the industry that, yes, CDMA had some potential. Secondly, we had the chips, and we knew we wanted to go international. To have a system operate internationally, you need to have standards, and that means standards setting bodies have to agree to it. And so we had to go stop everything and go through a standard setting process. Finally got everybody to agree to that. And that took another 1.5 years, so it was about July of '93 when we finally got the standard finished. We then worked hard to get commercial systems. The first commercial system was in Hong Kong in 1995. So it was 7 years from the moving to start studying CDMA to having the first commercial system, which was actually quite rapid. Why Hong Kong? Well, everybody had cell phones as their office, small island, heavy need, or great need for capacity, and so they were the first to take a chance. Second was over in South Korea, and then here in the US. It was interesting, all the phones that were used in Hong Kong, South Korea initially, the US, were manufactured in San Diego, because we were the only ones that would take a chance on manufacturing them. We had the chips, we had the expertise, and so we were building up a handset manufacturing business. I mentioned South Korea. That's another interesting case. Every country that we went to has its own story, but South Korea, we wanted them to come in. We wanted to get another country at least to come in early, and the argument we used in South Korea was they were building up a manufacturing industry, but to that date, all they could do was follow Japan into some various commercial products. Therefore, they could only compete on price. And here was a chance, still an unproven technology, a chance to, Japan was going with TDMA, a chance to go with something that if it did indeed win out, they would be ahead of Japan. They could build up their own cellular industry. At that time, they had none, and could end up with a new means of export product as well as using internally. As you know, of course, Samsung is now the largest manufacturer of cell phones. LG is a major player. That has turned out to be a complete success as well, but they took their chances with us also. The next step we had to get through was, do we keep making handsets? Do we keep making the infrastructure? We wanted that to be a worldwide business. If we're making the chips and building some of the equipment with those chips, nobody would believe that we weren't waiting to give them the chips until we had a good head start. And so we decided strategically to sell the handset business, sell the infrastructure business, and that occurred basically in 1999, early in the internet bubble that you might remember. Somebody mentioned the stock price. that year, Qualcomm went up by a factor of 26. I don't think anybody's ever done that before since. Of course, things came down a bit as well, but we're still very much in business and growing. In any case, let me jump to today and move ahead on some of this. The second generation was a battle, people call it a religious wars, between CDMA and TDMA. For third generation, which was to provide both voice and data over wireless, everybody agreed that they had no choice but go to CDMA, and so that battle was over, and CDMA is now a worldwide technology. And we're now moving into a fourth generation, which is based on yet another technology called OFDMA, which, again, we work on very actively, way well ahead on that. But the devices that we're now all interested in, the smartphones, the tablets, et cetera, are getting to be very powerful. And that's because Moore's Law, predicted back in the 60s, I think, said that every year and a half to 2 years, the number of transistors that you can fit on a piece of silicon will roughly double. The power they use will come down. The cost will come down. You get a free lunch, in a sense, every year and a half to 2 years. And that's still going on. So powers of 2 go up very rapidly. So I mentioned it took 3 chips just to do the CDMA initially. Now on a single chip, I've kind of sketched out, on that one chip, you have part of it that has 4 little computers, a digital signal processor or 2, a GPS receiver, global positioning system receiver, graphics capability, so you can get 3-dimensional graphics on that display, ability to take pictures with many pixels and adjust them for the color, et cetera. In fact, now we even make sure that you're smiling before it lets the camera go ahead and take the picture. The latest we've been able to show, I think everybody's now aware of high-definition television. That's so-called 2K, 2,000 lines vertically. Now there's 4K, the next super HD TV. On your cell phone now, you'll be able to take 4K videos and show 4K videos, or if you prefer, attach them to your display so you can see them on a larger set. So just tremendous progress. And one way that I always astound myself on the progress, in 1977, at Linkabit, we got very excited because a company called Digital Equipment Corporation, DEC, came out with a mini computer called the VAX 11780, which was fantastic at the time. You can see a couple of racks of equipment. On your one chip, on your handset, you're getting the computing power today of 10,000 VAXs. So the game has changed tremendously, and that's why we're able to do all these fun things on our devices. Well, as a result, both of these devices coming along, of the fact that people are finding cellular, and I'll touch on that more and more, we now have more than 6 billion, probably about 6.5 billion mobile connections today around the world. There's only 7 billion people, so obviously some people have, in a sense, more than one. And in fact, we're going to a situation where there'll be many more mobile connections. A lot of those will be machine to machine than there are people. But it's obviously a very rapidly growing area, and the digital communications part, the 3rd and 4th generation equipment, continues to grow, and we're aiming toward 4 billion with 3G or 4G very shortly. Apple came along with the iPhone a few years ago. Until then, I talked about smartphones having the capability to do many different things for you. A number of people are always skeptical. I can hardly learn how to use a few of the capabilities for telephone, for voice communications. How am I going to learn to use all these other things? They came up with, of course, a brilliant interface that's now converted everybody over to recognizing that rather than carrying many devices, one device is going to take me a long way, particularly as the screens are getting larger. And so smartphones, the installed base was 1 billion last year and is, again, rapidly growing. It's over 50% of cell phones in the US are smartphones. And more people are finding that they can't go without their mobile devices with them. So 84% have the feeling they can't do without it. 65% would take it with them instead of a lunch. This was a Time magazine issue that just came out a short while ago where they went on and did some polling. 44% would rather leave their wallets behind. Now, that actually has some sense to it because very shortly you won't use charge cards, you won't really need money. It's all going to be handled digitally through your cell phone. Whoa. Wrong button. The other aspect is connections to the internet. And the yellow line shows the growth of fixed line connections, the wired connections. The blue is mobile connections. And you can see what's happening. More and more access to the internet is via your mobile device. And in particular, in the developing countries, that's the case. And if you look at what's being carried on those, more and more of it's getting to be video on demand. A lot of the bits are being used for video on demand. Some of it is brought to you watch a sporting event, you watch a particular news event, everybody will watch at the same time. We can kind of handle that through a broadcast approach. But often people want to watch their YouTube or watch something else, and one needs more and more capacity. We've taken it on to say, okay, how can we get, we used to talk about 50 being great, how do we get 1,000 times the capacity? And so that is now well underway. Now, one of the limitations is there's only so much radio spectrum. The low spectrum for having large cells that where you have a cell station that can penetrate a building, that's these lower sweet frequencies. As you get a little higher, we're going to a number of small cells that you might have in your house or your office that will, now with the technology we're providing, leak some energy out onto the street. And so rather than having to use a large cell as you drove by those houses or offices, you can actually cheat and use that energy from the small cell. And so that gives you some substantial increase already in capacity. And we're moving toward in-building, going to much higher frequencies because we're going to the case where you receive things on your handset, but then want to transfer them to your large screen 4K TV, and you need a lot of bandwidth, et cetera, to be able to do that. So lots of things are happening. These small cells I mentioned, you can see they indeed are small. This is still probably early in the game, so they will become smaller, but smaller than a deck of cards, and handle the 3G, the 4G, the Wi-Fi, and provide coverage that's within the building and outside the building. Less expensive than a handset because they don't have a display that you have to pay for, and in some cases they don't need even the battery. Okay, where's everything going? Well, one thing it's often referred to is the Internet of Everything. Perhaps the first of these was the Amazon Kindle, which you read books on, but you can order books on. When you order the book, you pick one. What you don't know is that that choice is going out over a cellular network to Amazon. Actually, initially used to come through our operating center at Qualcomm and then up to Seattle. Then the book is delivered over the cellular network, but you don't think you're making a cellular call, you're just ordering a book. It's transparent, the price is included in the price of the book. And so more and more we'll be seeing various uses where it's a machine-to-machine, where you're not aware that something is being used cellular. You can see on the middle right, we have a dog collar that tracks where your dog might be. If it goes outside of an electronic fenced area, you get an email that says your dog just wandered outside of X, and you can go look for him, and in fact, with the GPS, it tells you just where that animal might be. People have often said, why dogs? Why not children? And it was an economic issue. People were willing to pay a little bit more for their dog than their child. Energy is obviously getting to be more and more crucial, and so wireless devices will monitor what's happening both in the home and in transmission, generation, and help adjust ourselves to what's happening around the world. And then cars are, of course, have already, and trucks, already have a large amount of communications. That's only continuing to increase, more and more safety features, ultimately perhaps on freeways, highways, some initial driving without the driver, but earlier than that, the ability for the car to warn you if there's a dangerous situation occurring. And ultimately, as you've read about with Google, perhaps autonomous driving sometime in the deep future when we figure out how you handle the insurance. Much more rapidly growing these days is mobile health. And this involves sensors of various types that you can either have on the device and it scans you from a slight distance, you can have on a smart bandage that's on your body, or with nanotechnology, devices that you swallow that make measurements, and with wireless and personal area networks, very short range, low power networks, communicate to your cell phone. Cell phone has a lot of computing power. The latest programs takes the signal out of all the noise you typically get from biological measurements and can alert you, alert the family, alert the doctor. So this is a rapidly growing area, and in fact, I often say in San Diego, where we have a very large wireless cluster, a very large biotech cluster, that this probably will be the next major growth area. Already a number of small companies working in the field, and Qualcomm very much working along with them. So all types of interesting possibilities in that area. And to kind of nudge things along, we came up with an X Prize that we refer to as a tricorder, but a challenge, a $10 million challenge, to come up with devices that when you hold them near you, as they did back in the original Star Wars episodes, Star Trek episodes, I know I was going to get that wrong, that it would tell the doctor what was wrong with you and how to do something about that. So we've got that challenge. I think the details are all up, and there are many, many teams working on that, so that's going to be fun. Another area that gets a lot of interest is something called augmented reality, and we've seen this, of course, in our televised football, where there might be a first down line drawn that's really not on the field. The players can run over it and it doesn't get in the way or anything. It's augmented, it's not really there. And so one of the early uses we put to this is you might be in a foreign country, there's a road sign you can't read. It would be very helpful if you could read it. Hold up your cell phone or your tablet and it gets translated for you. So it's able to recognize language, recognize locations, do a lot of computing to make all this happen, have an internet, the cloud as a database available, and so be able to do those kinds of things. Others, I mentioned communicating with your TV sets at home. One of interest might be you pick a picture out, you say, I'd like to put that on my TV set, so you move it by looking at it through your cell phone, and then give away your cell phone, and there it is up on your TV set. And these we do have up and going. Again, another example. The one that I find most important to me personally is the ability to have a little camera on my glasses or on my earpiece or use my phone itself, so that when I walk up to somebody, it looks at that person, whispers in my ear, or gives me a written message. Not only who it is, but what the last thing I had to do with them was involved, so that I can at least act a little bit more intelligent. That is becoming more and more important. Lastly, let me just go through a few things. With all these cellular connections around the world, what are some of the social good? What are some of the areas that we might be able to use them for to help people in their ordinary lives in a very positive fashion? We set up a number of years ago something we called our Wireless Reach program. Now we have, at last count, 84 projects in 33 different countries. I'll touch on a few of them. But the idea is that penetration of cellular is going up very rapidly. The use of cell phones going up very rapidly. We were just in Africa a month or so ago, and you talk with people, and once they have a roof and a little bit of food, the next desire is indeed for their cell phone. So penetration is moving up very, very rapidly. how do we make use of it? So one of the early ideas several years ago was with microfinance. We put a box together with a cell phone, an antenna, a battery, contract with the local telephone company, marketing materials, and an arrangement with a local bank. We sold those typically to women, and they would go out and sell cell phone service and keep half the price, and they were making a good living. That worked well for about a year and a half, 2 years, but it's turned into not such a good business lately. Why? Everybody's buying their own cell phone. So that part of the business is going down, ability to sell minutes. And what we've done, though, is provide them with a whole set of other applications, such as some of the mobile banking or money transfer apps, and they use those. And so once the women have had this taste of being entrepreneurs, of more than doubling their household income, they now take to these new approaches, and that program is still going on very well. It's when we started with the Grameen Foundation. We always work with local partners to set these programs up. Another early one had to do with helping fishermen in India. And there we provided some apps that would allow them, of course, to know the weather conditions, but also know which fish were biting where, but most importantly, what price they could expect in different ports when they brought those fish in. And so it began to help them very much with their finances, and also began to eliminate some of the middlemen. So the fishermen themselves were able to do much better. That has actually expanded, so now we have several other, that became commercial in India. We expanded it down to some more primitive, actually, fishermen earlier down in Brazil, and that's been expanding very rapidly. You can do the same thing with farmers, give them information, what insects, what problems can you expect, how do you deal with those problems, what will you get paid for different crops, where might you sell them, et cetera. And again, that started in India, moving ahead very well. I mentioned medical before, all kinds of potential medical applications. The simplest perhaps is there's a rural clinic, really gets doctors when it does. You might want to have some equipment there that allows the doctor to make measurements, send it back or if there's not a doctor, nurse practitioner, or some kind of practitioner, send that information back, get information on what to do about the problem, and have that sent back wirelessly. So those kind of assistance for clinics has been spreading very rapidly. A recent one is in South Africa, where we're getting much more now into the whole health database information, electronic medical records, et cetera, and providing support for health care for a variety of people, again, working with local partners. More and more of the population is getting elderly. One of the issues with elderly people, of which you have an example here, is that they may have some disability, they may have some need for communication, an emergency situation. Well, cell phones have sensors in them. So for example, if someone fell down and didn't move for a few minutes, the cell phone can know that and take it upon itself to call a family member. And so there's a lot of different things that you can do with these devices, and again, working with different partners, we are working on a variety of those. Similarly, one can, here in the US, look at different caring situations, and again, tying in a lot of the measurements being done with sensors, with health records, et cetera, and both improve the quality and reduce the cost of health care. Once we get the government to agree on how you finance these things, how do you pay the doctors, et cetera. Similar program in China Mobile. It started actually a program to help blind people, so it gave them their location. If they got lost, they could hit one button and that would bring on an operator who knew where they were because of the GPS in the cell phone and could provide them information. That program continues to expand. Other programs, and I'm running through these fairly quickly at this point, but different ways, again, of providing health care. One possibility is dermatology, skin problems. Take a photograph with your cell phone that's sent off to a doctor, gets back with the information on how best to treat that. Spain, working with disabled people or intellectually challenged people perhaps, and this is something I think that more generally is very useful. In fact, the military makes a lot of use of it. Virtual reality, so you have a piece of equipment, how do you do a repair? Well, you can hold it up, your phone or your tablet, it recognizes the device, give it a little information about what may be wrong, it pulls up the right information, displays it with step-by-step pointers as to how to proceed. And so a whole way, rather than having a stack of books you have to thumb through, of having this augmented reality help you with instruction. And finally, education throughout the world, wonderful sound. I think we've been talking about technology used in education to support teachers for a few decades with very little to show for it. This decade, clearly, a lot is happening, and by the end of the decade, I think we'll have made very substantial differences at K-12, pre-K, and undergraduate and graduate education, as we can see happening around us. And so we've been looking various ways with augmented reality to expand the textbook. You look at, in this case, they're looking at some flowers, get some more information about that particular plant, whole range of different experiments being done there. Back in the year 2000, I was with President Clinton at the time in Whiteville, North Carolina, a very poor community, had been based on tobacco farming, but that had pretty well gone downhill. And so there were small businesses, and the idea here was to show how a high-speed connection to the internet could help a small business. So we're at an environmental manufacturer, and at that time, the high data rate, the third generation, was still experimental, so we set up an experimental system so that we could demonstrate the capabilities. President Clinton got quite fascinated by this. I don't think they let him near a terminal in the White House, and it took an extra half an hour to kind of drag him away from this demonstration and back to a roundtable discussion, then a press conference. In any case, Governor Hunt at the time was there. I promised him we would, once these things were no longer experimental, come back and do something in North Carolina. And so 5 years ago or so, we set up what we call Project Connect, which was giving smartphones to students in 4 different high schools, typically next to military bases, relatively low-income students. And we prepared some curriculum materials, some suggestions how to use this, information for the teachers, for the students. At the end of the first year, there was one high school in particular with a teacher that had one class with the smartphones, one class without. And as noted, the class with the smartphones, 100% of the kids passed their Algebra 1 state exam. In the class, same teacher, without smartphones, only 2/3 passed the exam. And so we're saying, what's happening? What's going on here? And in talking with students and teachers, it turned out that much of the value was the 24/7 availability of the smartphones and the internet connections. Student would go home, try to do a homework problem, can't solve it, ask the parent can't help. Rather than waiting until the next day, could get on the internet, talk to some other students, and be able to move ahead. And then some students would come up really a clever way of solving a problem, video themselves, and send that around. And so we're getting more and more 24/7 peer-to-peer education. And of course, any of you who are teachers know the only way to learn something is to teach it. And so that turned out to be very, very valuable. And so, great believer now, mobile devices, no longer a laptop per student in the classroom, obsolete. Mobile device for the students to have with them at all times that they can make use of. And of course, the ability to have the textbooks no longer paper, all digital, and therefore you can keep them up to date. And even more so, students read through. I know this well, I can skip over that. I don't know this so well, I can get more material immediately to fill in. That information's passed back to the teacher. Teacher always knows where in this whole process the student is. The problem with doing this is that having internet connections available 24/7 outside the classroom is expensive. We did have the FCC, as a result of this Project Connect, set up a program a few years ago where they set aside $10 million to support several school districts. It was competitive, 19 school districts and 1 library district, providing support for the students to have that 24/7 and internet connectivity. And now they're in the process of evaluating the results of that, and I'm sure that indeed this is the future. In fact, we were just in Myanmar a short while ago on something of a political visit, but in talking with the communication, they were getting ready to go out with a bid for new operators to bid for spectrum. We suggested, I'm not sure it'll happen, it was a little late in the game, that they require that some capacity be set aside for education and for medical uses of that interface. So lots of things are happening. Many of these affect all parts of our lives. They certainly affect the transportation side, as well as just about everything else with which we have contact and which we're interested. Thank you all very much.
Thank you very much, Dr. Jacobs, for this most stimulating tour of the wireless world and your experience in making it happen. We have time for a few questions. And we have a couple of students with microphones on both sides. Those, if you'd like to ask a question, please raise your hand. And when you have the microphone, please introduce yourself and ask your question. Who would like to start?
Hi there, my name's Ben McLean. I'm a Northwestern graduate, a computer engineer. So I found your whole speech just very fascinating every step of the way. And I also work for a transportation firm called Irwin Transportation Management Systems. So, first off, I'd just like to say thank you for what you've done for our industry in terms of making it safer, more efficient, more fuel efficient. What you have done in our industry has been nothing short of amazing in terms of those technology increases for those of us who operate vehicles. One question, you start with, and you showed some of these devices, and you're still the largest installed base for big commercial truckers, yet there's all these new devices, there's a proliferation of mobile devices. Every driver that we hire today already has a device. They may run an iOS or an Android operating system. So the computing power is already in their hands. And our industry is very competitive. And any way to cut costs or be more efficient or reuse bandwidth, it would be seen as a positive. So do you see this proliferation of commercial devices, personal devices, making its way into the commercial world, and how is that going to affect your transportation business and the hardware that you deploy today in commercial fleets?
Right. Well, already we kind of did ourselves in one sense as far as our satellite communications business. It's still a very good business, but more and more of the data is carried over cellular data connections. And that's only going to continue to expand because cellular gets better and more broadly available. And so it can support trucks even in fairly remote areas more and more. And so for the time being, there'll be some hybrid solutions, and then more and more moving over to personal devices, bring your own, or company-owned devices. But the key aspect is going to be all that software that we have developed to make the satellite systems available, tie into your logistics systems. All that, I think, will continue to be very valuable. The measurements being made on the trucks will, independent of how it's being transmitted, be important. Position location, important. Of course, that's in cell phones now as well. And so there'll be a transitioning over more and more of the communications being done through cellular, but the basic business of communicating, staying tied together, that's going to continue. And we'll have to keep learning how to do it better and better.
Thank you again for being here.
Good evening. I'm Gilles Bouillet. I specialize in software development. I follow an MSIT program in McCormick. I'm curious about contextual awareness and gimbal. I understand it's one of your leading software company supporting contextual awareness, and I wanted to have your feeling on where you would like to drive that company and where you expect the improvements and contextual awareness to drive us.
To drive the company to do what? I'm sorry, I didn't quite, my hearing.
Yeah, sorry.
Better.
So contextual awareness, the potential of developing software around it and applying it to the world. With gimbal.
Did you get that? I'm
Yeah.
sorry.
So contextual awareness is one of the key mobile sectors into
Right.
which companies are going to develop application. And you have in Qualcomm gimbal.
Yes.
And I wanted to have your opinion on where you want to drive gimbal in this sphere of software development. Thank you.
About 10 years ago, probably longer than that now, about 13 years ago, we began to recognize that telemedicine, mobile health, could in fact be a reasonable future direction to pursue. And we hired a few people to start looking at that. And we've now spun off a company, subsidiary, to look at mobile health areas. And that is, and we have a venture arm, and we've invested in a number of companies that are making new sensors of various types to sense different aspects of the body. We also have been working with hospitals and others, equipment manufacturers, medical equipment manufacturers, to say, okay, we got all these disparate equipments in a hospital that never communicate with one another. That's not very efficient. How do we build a device that allows all of them with whatever their protocols, kind of the internet of the medical equipments, be able to talk to one another? So we have that effort that we're out there working with right now. As I mentioned, I think this whole telemedicine area is going to be a huge growth area. Improving quality, reducing cost. One aspect, we can talk with the different medical hospitals, teaching hospitals, whatever. One of the problems is that typically about 20% or so of patients that are discharged from a hospital end up coming back again. And why? Because once they're out of the hospital, nobody's really watching them carefully. If one can monitor certain functions that need to be monitored for that particular patient, and then be able to be aware of the problem earlier, one can perhaps prevent this need to return to the hospital. We reduce that fraction considerably. So we're still in the very early stages of this process, but significant gains are being made. And part of those are because we have improving sensors that are still generating very noisy signal, but with the cell phone and computing power and the technology we built up in communications for pulling signal out of noise, one can look at those signals, get value from them, and then make good use of them. So as I say, I think we're still on the early side on the sensor, on the software, on the economic side, on teaching doctors and others how to use it, on the medical records piece of it, on the privacy side, and there's a whole range of different issues that are being dealt with. But again, this decade is going to be a huge impact.
Questions?
My name is Oliver Gould. I'm a retired electronics distribution chief and an investor now. I'm curious to know what you see as the future of the manufacturing capabilities in the United States versus overseas, especially with the fabless companies, pretty much such as yourself. Do you be able to see that with the fabless business as it is today, that this can be brought back into the United States to have more manufacturing facilities in the United States as opposed to the Orient?
Right. That's obviously an area of great interest, lots of, at the political level, at the university levels, at the business levels, trying to figure out how do you get more manufacturing. There's one thing that one needs to recognize, that manufacturing is changed quite a bit. It will continue to change, and when we get it back, it's probably going to generate a large number of higher paid jobs, a small number of people working, but needing more training, and so it won't be quite the assembly line type operations where we had many workers doing repetitive tasks, and therefore, in some sense, getting into the middle class by doing that kind of work. I think manufacturing, and this is both a disadvantage but an advantage, it's an advantage for getting it back here, with high technology and robotics, et cetera, and the ability to be able to change models very quickly, because lifespans are so short these days, needs to be automated. That doesn't require very many workers, therefore, but they will be better paid. I think that kind of manufacturing is coming back. It's a little difficult once you lose a lot of it, because it's not just a plant, it's all the suppliers, it's a whole ecosystem of suppliers as well as manufacturers that need to come back, and so that will happen gradually. Now I mentioned early, manufactured phones and infrastructure in San Diego. When we sold those divisions, we required that they continue to manufacture. We don't want the people to lose jobs, at least for another 5 years, and that did happen. But over time, all that manufacturing of cell phones has moved offshore and largely over to China, some to Taiwan, but largely over to China. And so all the suppliers that you need to make the devices are over there. One of those devices is the chips that we make, and a lot of our foundries, we don't have our own foundry, we use other foundries, commercial foundries. A bulk of those are on Taiwan, Singapore, South Korea, but one of the companies is now building a new foundry here in the US, and I suspect, again, because the labor is down, if we have reasonable prices for electricity, and of course with the abundance of natural gas now available, that is no longer a large issue. I think we will be seeing more and more of that manufacture coming back to the US. So these things happen. The other that's happening is in transportation. If it's heavier things that are being built offshore, you bring them back on ship or by air, but in particular on ship, you're already using a lot of fuel, generating a lot of carbon. That's getting more and more expensive. And as a result, if you can build it locally where it's going to be used, you can save that part of the cost. And so there are a number of drivers, I think, that will say that we've probably hit the low point and we're going to gradually start, I'm always an optimist, but that we're going to gradually start improving.
Hi, Dr. Jacobs. My name's Brad Winters. I'm an undergraduate here studying industrial engineering, and I'm actually very interested in kind of like commercial smartphones and tablets. One thing I've kind of been noticing is that it seems like in terms of the chipsets, the smartphones and the tablets are very similar, and what differs is the screen size, but essentially the capability is very similar. So one question I have is, as the computer starts to phase out, and you start to see kind of this divide between physical keyboards and virtual keyboards, and then kind of the combination of screen size into that, how do you see the smartphone and the tablet kind of converging, and then where do you kind of see that going from where we are now?
Right, no, you're quite correct that the capabilities in the tablets and the smartphones are more and more overlapping. The main difference is the display device. And so the question is, what display device are you comfortable reading a book, looking at a textbook, doing whatever work you might wish, looking at spreadsheets, and so on. One of the things that's happened recently is that the displays themselves, the resolution has gone up greatly. The number of pixels per inch have gone up, and the number of inches have gone up. And so the main difference now is the size of the display. If you have, we're moving very much towards, say, 4.75-inch display, some a little larger, some a little smaller, but that's the size display you can do an awful lot with. And the tablets started at 10 inches, some go 11, some now going down again towards 7. And so there'll probably be a variety of products to suit different people's desires. My own guess is that more and more the 5-inch or so smartphone and maybe the 7-inch tablet, they're very close, but one's easier to carry around, may end up taking up a larger share of the market because of the good screens, but also because of this other thing that I mentioned, that if you go into a room where there's a larger display, a large TV set or whatever, that you'll be able to wirelessly connect to that. And so where you're not moving around, you're not in a mobile situation, you'll be able to get your large display. The other aspect, of course, is the keyboard. The larger the device, the larger the keyboard, although tablets typically have touch keyboards, as do smartphones. Now, as you've noticed, we're getting more and more voice inputs. Those work well where it's a relatively quiet situation and you're not going to bother anybody with that voice, so there'll still be the touch approach. But again, if you're ever sitting down, you're not on the move someplace, you can take out a small folding screen and make use of that. Looking a little further ahead, Google has been making a lot of play toward having smart glasses with a little display off to one side. One can certainly project what appears to be very large images back on your eye so that you may even stay with a small device, but it's talking to something on your eyeglasses and giving you the feeling that you're looking at a very large display. Or if it's augmented reality, seeing the world out there plus some additional material. So it's going to be interesting to see how that itself moves ahead. So there's a whole range of these different possibilities. I think there'll always be several different sizes and forms because we all have different tastes. What I think, though, is quite clear is that the laptop size machine, the one that you kind of lug around, that I still lug around often, is going to go away. That either the phone itself, and these days I read my newspapers, I read a lot of my books on my phone, or tablets will replace that. And that gets back to another interesting commercial battle in a sense that's going on, at least some other people call it a commercial battle. But Intel, of course, has been very strong and been the source of the parts for the desktop and the laptop, now going down toward smaller. They've used what's called complex instruction set computing. Remember, I early on mentioned reduced instruction set computing. That instruction set is largely now licensed by a company called ARM. We early on went to reduced instruction set because it has a number of features that allows you to get by with more computing for less energy. Intel has stayed, although they bought some companies and then resold them, stayed with the complex instruction set computing. But they think that they'll be able to still be very competitive. So there's a bit of a battle going on as they come down to smaller devices that are run by batteries. We come up to larger devices that are run by batteries, both of which need a large amount of computing power. Who's going to get a significant share of that market? I suspect the answer is there's room for more than one company, obviously, and the market's going to continue to increase. But that's going to be an interesting little bit of a battle to watch.
I'm going to use my prerogative and ask you the last question, Dr. Jacobs. You pointed to several opportunity areas, particularly towards the end of your presentation, in terms of mHealth and, in the health area, in terms of innovations in education and so on. And these really are new domains. They're potentially new industries that will need new workers, essentially. And the question is, how does one ultimately get into these things? And I'm thinking here in terms of advice to some of our younger folks who may be interested in in going into some of these areas, because typically if you are trained as an educator, you really don't have the capabilities to use the technology that we're looking at here. Similarly, if you're in the health domain, often, you don't have the technology background for it, nor do computer science folks have the health knowledge. And so how do you see that moving forward?
Yeah, well, first of all, I'm a great believer when you're in the universities or beyond to get a very strong basic education, to be very deep in at least one area, and then be open to being broad in a number of areas, and therefore be able to work with others that might provide the expertise that you might not have. So I'm a great believer, again, of getting that good theory background, the good theoretical background in one or more areas that by their nature will have to be somewhat narrow, but then being open. I'm a great believer in being opportunistic. We just can't predict even out 5 years, it can be pretty good, but beyond 5 years it gets really hard. Because things change rapidly, new ideas come up, new approaches, new interests by consumers or businesses or whatever. And so you have to be optimistic, be prepared to change, and look at new things. Make sure that you have the resources set aside if you can, not doing nothing, but available to be reprogrammed into an area that suddenly does become exciting. If you're running a business, you might always be looking for a person with a certain expertise. My own belief is you look for somebody who is awfully good in some area and hire them and then kind of reshape the operation to make best use of that expertise. Finally, both in the case of the teachers, but of all of us in a very rapidly changing world, we're more and more going to take advantage of what technology can offer as far as bringing new information to us. So you've all heard of the MOOCs, the massively open online courses. They have their supporters, some detractors. I think they're having a massive impact, and that we're only beginning to find our best way to make use. So more and more excellent material is going to be available in a fashion that's accessible to many of us because of this improvement in technology. So the technology presents challenges, but it presents opportunities as well. It's all a balancing act. We're in for a lot of fun.
Thank you very much, Dr. Jacobs.
Thank you.
For a most stimulating talk, and thank you all for joining us this evening. Thank you.